I want to talk about the timing constraints of a flip-flop, which are known. Two of them I will actually talk about: TS, which is the setup time, and then the TH, which is the hold time. So these two times, let's see what they are. If we look at a D flip-flop, it applies for T flip-flop or JK flip-flop, but let's do it for D flip-flop just for the understanding. So this is, let's say this is the clock wave shape and this is the input D. Now when we have that, I will probably erase this part first because we'll talk about this thing later. So we can see that the clock edges are here, this one, this one, this one, and the input D is changing before the clock. Now there is a time for a chip that within the before the clock edge changes, within a certain time the input cannot change. That time is called setup time, TS. So maybe that one is this one. So we can see here the input changes longer before than the setup time. Like here, this one, the input changes. So for this clock age, the setup time will be the same. Let's say this is TS, this is also TS, and this is also TS. So all of them TS. Now here it changes before setup time, so that's fine. Here it changes, here's the changes longer before than the setup time, so that's fine, and we will get the normal operation. So if Q, we need to draw Q. This one will become 1 here, and then here it will stay 1, here it will become 0, like that. So that's fine. Now if for some reason the input changes within the setup time, yeah, it's gone totally. Now let's say this, in this situation, these are the clock edges and the input changes within the setup time. So let's say the setup time was something like this, TS, but this one changes here. So if that happens, the flip-flop cannot identify the input and it goes into indeterminate state. So the output will be undefined state. Here again, if this one is, say, setup time was like that, so it is changing, the input is changing within the setup time. So in that case the output will go into undefined state, and here it will be undefined. But here this one, let's say there is another parameter which is called hold time. I haven't talked about it yet. Let's say this one is not, it's satisfying the criteria, so this one will go into high state. So this one will work because this is the setup time. We can see that this is here, it's longer than setup time, and this one is another parameter which I will talk soon, but this one goes there, and this one again, it's changes within the setup time, so it will again goes into undefined state. So that's the thing. This is a constant timing parameter that the input cannot change within the setup time, and setup time is the time before the clock edge comes, within which the input cannot change, whether it's high or low. Similarly, the hold time, which is the other parameter, is the, or other timing constant, is the input cannot change within a certain time after the clock edge comes. So here in this case, let's say this is the hold time maybe, and this one changes again. This one goes to from high to low, but it happens after the hold time. So if this much is hold time, this one happens after the hold time, so that's fine. The flip-flop will read it as an input. This high, it will read it as a high, so that's fine. Now similarly, maybe I will do one more. So basically if I do it like that, so let's say the hold time is something like that. this much. Now this case, this is fine, this is not fine, this is another one. So this one it will read as an input, so this is one D, this is another D. This one is within the hold time, it's changing, the input is changing because this much is the hold time, but this is the clock age and this is the hold time, but this one is changing within the hold time while this one is changing after the hold time. So this one is a valid input and this one is an invalid input. So it's the same before and after. So basically in practical circuit, the clock edges are never as straight, clock and input edges, so they are something like this, let's say like that. And if we say this to be the effective level for a rising edge clock, the input is say here, it changes, and then here it changes again like that. So this is D, this is clock. And if we define the setup time here, let's say this is setup TS, and let's say here this one is, say this is hold time. So we can see that this one, this is where it changes, so it changes maybe somewhere here where it can be effectively taken as a high. For TTL it will be around 2, for other logic it will be different, so that's not the point. The point is this one is high, so this time where it changes, this time is bigger than the setup time. So if I call it T1, it is greater than setup time, so this level will be taken as a high, as a valid input. While for this one, this is the hold time, but it changes here, maybe it changes somewhere here, or let's say the hold time is so it changes maybe somewhere here. So if I call it T2, T2 is less than hold time, so this one will not be accepted as a valid input, so this low will not be accepted. So maybe this one is the low signal, but it won't be able to accept it as the valid input. So yeah, I will do this part again. So let's say this one is the hold time here, TH, and we can see that the input changes somewhere there. So this is a better drawing here. So this is the time where it changes after the effective clock age, the input. So that's T2, let's say. So T2 is less than hold time, so this will not be accepted as a valid input and the output will go into undefined state, indeterminate state. So that's the thing. Hold time, this setup time was valid, and setup time, it met the criteria of setup time in this case, but it didn't meet the criteria of hold time. Now let's say this is another one here, and let's say the output changes, input changes somewhere there, so maybe the hold time is here, but this time, this change time is greater than, so if we say T3, and this one is, so I'm talking about a falling edge clock now, so this one is T3 is greater than hold time, so this one is the hold time, so this one will be taken as a valid input. However, this one is a falling edge clock, so the clock that goes like this. So yeah, this is pretty much the basic of TS and TH, and they are not necessarily the same, they are of nanoseconds, say 12 nanosecond, 9 nanosecond, or even less. So yeah, I will do few more videos on this. So